Hi everyone. I thought I'd do something a little different tonight and record a video demo. Normally, I sort of write text tutorials or um, highlight some of the stuff I've been doing in a dev blog just to help me remember some of the steps that I've done to make cool stuff. But I think what I want to do today is overly visual. I've actually tried recording this once on my desktop and it decided it didn't want to work, so I'm going to try it again on my laptop. So, for those of you, I guess, who would like to know, I'm a um, I guess intermediate programmer. I've been doing it for about 4 years, and I was really inspired the other week by a video that I watched on YouTube and also some threads that I read on Reddit, basically about juicing your game and how you can add little things to your game to make them feel so much better. I'm actually in the middle of a 48-hour game jam right now, and I'm probably supposed to be doing work, but I thought I'd take about an hour out of my time and write this demo. It will help me remember, I guess, and also I think it's pretty fun and pretty useful to everyone. So bear with me. This is my first video tutorial. I'm sure I'm going to stuff up quite a bit, but if people are interested, I'll make a concerted effort to get better at it and do them more regularly. So for our game jam, we're making a car racing game, and I won't go to explain too much of the details, but basically we're going to have some power-ups, and my job was to juice them and make them feel good because right now they look pretty boring. So my friend Werner, he modeled these, and I think they look awesome. Like that base is so cool, and those chevrons look awesome. Like they're good looking models, but by themselves, just like that, they don't really do a lot. So I'll actually upload this Unity package that's pre-prepared and ready to go. I've got just the standard Unity car in, which we're not using for our game, but it was nice and simple to get set up quickly, as well as these three power-ups. I guess the only thing of interest that you really need to know is each of the actual power-up logos, so the chevrons, the shield, and the up arrow, they all have a box collider attached to them, and that box collider is a trigger. I like to use triggers for these types of events because um, I don't know, they don't feel as like physics heavy to me, and they don't deal with collisions, and I sort of feel like that sort of stuff should be left for other things. So I'll be using them as a trigger. You could use collisions if you wanted, I guess, but this seems like a good way to go about it. What I'm going to do quickly, because I had issues with it today, it's fine. So I'm going to show you a few really simple steps on how to juice these icons and make them look really good. So the first thing we'll do is we'll create a, that's not what I wanted to do, we'll create a new folder called scripts, and then inside that folder we'll create a new C# script and we'll call this power up. So I'm going to make a base class or a parent class for this object, and basically what that's going to do is it's going to allow me to add a bunch of common features to this object that I'll use across all my power-ups. So even though each power-up is going to behave differently, the base behaviors will be there. So what it looks like, how it acts, things of that nature. So what I'm going to do is I'm going to quickly add some variables that I used today that I think worked well. So just bear with me for 2 seconds as I do this. Original scale. I'll probably speed this up. For those who are wondering, I normally would probably make these private and serialize them in the inspector. However, for what we're doing and for the sake of speed, I'm just going to make them public. So you can do whatever you want for this, but this seems like the quickest option right now. That's not right, that's better. So basically what I'm doing here is I'm just creating a bunch of variables that we'll use later down the track and sort of preceding them with some values that I think feel nice. So You might be able to guess from the sorts of variables we have here what we're going to do with it. So I have a rotation speed variable, which is going to allow me to rotate the object. A bobble amplitude, which is basically going to let me bobble the object. A scale speed, so I'm probably going to be scaling it at some point as well. And then a minimum and maximum spawn time. So, first things first, let's get started. Because we're making a base class, I like to make what would normally be private variables protected, so I can change them if I need to. I'm probably not going to need to for the one power up example that I'll show you, but I think it's good practice. Now, if for some reason you need to override the start method, you can. So first thing I'm going to do is just grab the transform scale, and we'll discuss that later. And I'm also going to grab its collider. Ooh. And the reason for that is at some point I'm going to want to turn the collider on and off, probably. At least off, definitely. And that's a nice way to do that. So, and then it's useful in any child class. I can just refer to it as collider, it's just easier. So what I'm going to do is I'm going to use the shield, probably. The shield had a bit more work in it. I'll use the speed power up as an example. So first thing I'm going to do is I'm going to add my power up script to it, right? So I can save my scene and run it. Nothing's going to change. I haven't actually written any code in the update function yet, but we can see the script is here and it's working and it compiles and that's all great. So this is all about juicing, right? So what's a really easy way we can juice something? Make it move. And how easy is this? I'm going to rotate my object, right? Now, how am I going to rotate it? Probably about the y-axis, okay? So the y-axis is what faces up. So let's create a new vector 3. Alright, it's not going to do anything just yet. So let's change the y-axis. Let's make it do something. So let's make it move by the rotation speed we said earlier. And of course delta time to take into account for the fact that we're only moving at fractions of a second here. So by running this now, once it wants to play, look at that, it's spinning. This is already infinitely cooler than the last one, and I've written one line of code for it. Well, two, I guess, if you include the variable. And look at that, how cool does that look? That's really nice and simple. I can change the speed. I sort of like it slow, but I mean you can make it really fast if you wanted. That looks sort of cool as well. Really, let's speed it up for the sake of the demo. So that's pretty cool, right? 50, and that was really easy to do. But I don't know, it still looks a bit boring. It's just sort of floating there. It's not really doing anything. So let's do something even cooler. Let's just take the object's position and we'll just store it in the vector3 called position. You can't always directly manipulate transform properties, and position is one of them, at least if you try to only directly manipulate one variable of that. So basically what I'm going to do here is something really simple. I'm going to do this. I'm going to then tell you why it's bad and then change it a little bit. It's not super bad, but so for those who don't know, a sine wave basically varies between -1 and 1 at any given point across the y-axis for any value of x, right? So I can pump in any time I want since the level's loaded, and it's going to give me a value between 0 and 1. And then again, because I'm moving in increments, so I'm only adding the difference between the last two moves, I need to make sure I'm multiplying by delta time. And then because we want to be able to juice it and change it and make it feel good, I've also got a bubble amplitude variable which we've set up here that will allow me to change that. So now when I run it, let's see, compiles my code. Look at that. Now it bobs as well. How cool is that? And that's, you know, that's two really simple things we've done, and we've added some juice. Look at that. That's so cool. I love it. It's awesome. And we can change the amplitude here if we wanted. I can make it really big, which would sort of be pointless. It will go into the floor probably. Oh no, 0.5's alright too. So you can make that bob really high. Now, I was given some pretty interesting feedback on this line of code that I wrote for my friend today, and he basically told me that the problem with this code is as update obviously doesn't run like regularly every time, at fixed increments. There is a chance that mathf.sion, if you keep adding these incremental variations together, it will never reset back to zero. And what they found is when they ran this over the period of about half an hour in one of their games, that objects started moving up, positive in the Y direction because of this movement. So there's a simple way you can fix that. It's just a little bit of change of code here. So basically, instead of doing an incremental move, we're going to find out where exactly it should be in Y, and basically remove the last frame's movement. Does that make sense? So it sort of is irrelevant for the first frame. But for the first frame, it's going to do whatever it's supposed to be at, minus one frame. So it's going to offset it, and then it's going to re-add it. And basically all that's doing is it's ensuring that we're always offsetting the Y value of the, what do you want to call it, the bobble from its original resting position. So instead of moving it incrementally, we're moving it, I guess, in an absolute fashion, and that way we're never going to get that creep. So it's still it should still operate the same unless I've broken the code. There we go. So it's still operating the same. It's just now it's always going to be fixed. That's just a nice little trick that I was taught today, which I thought was pretty cool. So I've left that in there. So this is already infinitely better, right? Like this feels awesome. Like in game, if you want to, you can sort of see it. I guess I can maximize the tab. Like that just feels so much better. I mean, yeah, it's probably rotating a bit slow, but that's way more attractive and draws your eye, and then this shield here that's doing nothing. So we've made a good start, but we can do better. So let's do better. So let's create on trigger enter method, and let's grab the collider if we need it. So this one's also going to be protected, so we can override it in a child class. In fact, this one's probably the most important one to override, because the on trigger enter is probably where all your functionality is going to go for the actual power up itself, which I'll show you later. So the first thing we want to do is enable the collider. And now I thought about it, do I even need to do that? Can I just like access the collider through collider? No, I can't. Okay, that's fine. So first thing we do when we hit it is we want to disable it, right? We don't want to constantly use it over and over and over again. So let's just disable it. Pretty simple. Now when I drive into it, I'm going to go back to the view that I had because I think it's better. Here. See? I've disabled the box collider now. So if I ran into it again, nothing would happen. That's pretty useful, but we should probably have some sort of visual cue that it's been disabled as well, and there's a heap of ways you could do this. You could, I don't know, change the color of the object, you could delete the object, you could change the image so it's like a big red cross. Maybe that could be sort of cool as well. I just thought, hey, why don't we scale it down? Okay. So the easy way to fix that would just be transform.local scale equals vector 3. 0, right? Just take the transform of the object and make it disappear. So when I run into it, left. But that's okay. But it disappears so fast, and it just feels a bit, I don't know, feels a bit flaky. So why don't we change that a little bit? Let's make a coroutine called scale object that we pass in a target scale to. And I'll discuss why I'm doing this in a minute as opposed to hard coding it, because it is pretty useful. Yeah. So the first thing we want to do is grab the transforms local scale. That's important because that's the variable that we're going to be changing. Yeah. And we say while that scale does not equal the target scale, we want to do something. Yeah. It's a coroutine. We want to do this thing over time. So we want to change our scale. We want to move towards the new value. So we want to move our scale towards the target. Again, we're doing this over a number of frames, so let's use time.delta time to our advantage, and we made a scale speed variable earlier. So what this is doing is every frame it's changing the scale and getting it closer towards the target. Of course, there's no point in doing that unless we set the object scale back to that new value. Okay, and we want to yield return new wait for end of frame. So the way this coroutine works is it's going to slowly tick down the scale until it hits 0, and then it will end. So instead of just having it end straight away, we can start a coroutine called scale object. We still want to scale it to vector 3.0 because we want it to go away. But instead of it just disappearing like in one frame, it should disappear over time. So assuming I've got all my code right, we'll just do this. Oh, look at that! It just disappeared. It probably disappeared a bit slow for my liking, so maybe 1.25 seconds. So it's basically straight away, but it's not doesn't just disappear. Like that doesn't feel right. This way you don't have to muck around with fancy particle effects or anything. It's just look at that. Woo! It's gone. So that's pretty cool. In fact, that's made it slower. So let's say 3 instead of 2. Yeah, that feels good, right? Like it's just it's juicier, right? And it's really easy to do. Instead of just doing something immediately, I'm doing it over time. I've already disabled the object, so up here before I run the coroutine. So it's not like running into it again is going to do anything anyway. So that's pretty cool. But then we can only use it once. And the problem with things like these power-ups is if they're a core part of your gameplay, you need to be using them often. That's what makes them fun. That's what makes the game fun. You want to allow the person to interact with these things as regularly as possible. And to be honest, before I started doing this sort of stuff, I probably would have had some weird like complex timer system in, or some sort of state checking to like work out when I could have this object respawn. But there's really a much easier way to do it. Like coroutines are amazing. Like learn to use them and sort of abuse them. Let's make another coroutine called respawn object. Yeah, and we're just going to. Whoops, I've hit my trackpad. Here we're going to wait for a random number of seconds. So we already know we already have a minimum and maximum spawn time we wrote before. So it's up the top here. So we've got a 5-second minimum and a 15-second maximum spawn time. So what this is saying is wait for a random time between those two values. Yeah. And then once we've waited, let's create a coroutine, or let's restart the coroutine to scale the object. Instead, it's already at 0, so let's scale it back up to our original size. This is why I cached this variable as soon as the object spawned, is because once the object is 0, you for some reason might want a really big power up or a really small power up, I don't know. But now, it doesn't really matter. I can scale this to whatever I want. I'm going to scale it back to the original size. We do have a bit of a problem with this though, don't we? It's that we don't really have a way of calling it in this code just yet. But we can add it pretty easily. So I'd probably do it here in the scale object class. So we say we've got two states basically once we've finished scaling an object. Either the scale is going to be 0. Oops. And if it is 0, then we're going to want to let it respawn after a certain time, right? Because it's disappeared, so after a random time, it's going to respawn. The other option is that the scale is the original scale, right? So we've either gone from big down to vector 3.0, or we've gone from 0 back up to the original scale. Now, if the scale is original, then we need to re-enable the collider so it's usable again. Because if we don't re-enable the collider, it's going to be sitting there and it looks like it's going to be interactable, but we won't be able to do anything with it. And the beauty about putting these at the end of the coroutine is that I guess all the functionality is sort of delayed until after the animation. And that's like it's super simple, right? Like, I have less than 56 lines of code, including all my headers and comments and everything. And I've gone from this here on the left, this just boring, plain old shield. Look at that, that's so boring. Look at it. It doesn't even do anything. And then this, look at this. It's spinning, and it's bobbing up and down, and then, if I can aim at it properly, boom, it's gone away. If I wait a second, it's come back. See? So that's awesome. Now I can use it again. No complex state checking, no weird timers or anything, no booleans to check whether the thing's supposed to be going up or down. It's really simple, super beautiful, and now I've got juice. So that's pretty much it. I can apply the script to all of these if I wanted, and I would have it working. So for example, I'm just going to go onto the shield here, and I'll add the power up script. What I'm going to do though is on the chevron is I'm going to remove it, because I want to show you how you would then implement just one power up. I'm not going to do it to all of them, but just one power up to this system. So I'm going to create a new script here, and I'm going to call this speed power up. So the idea of the speed power up is that you're supposed to go at double the speed when you hit that power up. So yes, I'll reload all. Yes, I don't know why it doesn't like Windows endings. There we go. So this is supposed to be a power up. Yeah. So by extending power up, I have all of this available to me here. I can't necessarily access all the methods, but they're all there. So now what's going to happen is on my chevron that used to have a power up, I'm going to add a speed power up. Now theoretically, this should run exactly the same. My speed power up doesn't have any new code yet. In fact, it's an empty class, so it behaves exactly as we'd expect. Oh, can I get the shield? Can I get the shield? Yeah, I can. Easy, right? So we know that extending that base class now has given us the ability to add some more functionality. And to be honest, the reason I'm showing you this one is because it's probably the quickest. So I'm going to make a new variable that I can see in the inspector. I'm going to call it speed multiplier. So this is the speed that we're going to change the velocity by, basically. So I'm just going to double it for the sake of this demo. If you're going super fast, that's probably really bad. If you're going really slow, you won't notice it. So there's probably better ways to do it, but this just gives you an idea on how you can implement a power up. So I'm going to use the new keyword, so I can override the base class's method. So on trigger enter right now, if I was to run into the shield, on trigger enter would call this code here, so it would disable the collider and it would minimize or scale down the object, right? Because I've overridden this now, for the speed power up, nothing is going to happen. I'm not doing anything, because this is where I'm going to be adding my own logic or my own code. So basically what I'm going to do for this, so I'm just going to do something really simple, is I'm going to grab the rigid body. It's on the root, I'm pretty sure. I'm just going to grab the rigid body off the object that's run into the shield. I'm just going to the root because I'm not sure which collider is going to hit the the shield, but I know that the very top object in the car has the rigid body on it. And then all I'm going to do is grab its velocity and multiply it by my speed multiplier, which in this case is 2. So just double its velocity. That's really simple. I'm sure there's other things you could do with it. You could, add angular velocity or do something crazy. This is just a really simple power up. Now, the problem with that is, by doing this, I no longer have the ability to have that cool like shrinking effect or anything, right? Because I've overridden that class, that function. There's a really easy way to bring that back, and that is just to call it. Now you'll see I'm getting an error here. If we have a look at our power up class here, on trigger enter needs a collider. Yeah, and the reason for that is you can see right here in this instance, I need to get the other object or the collider from the other object so that I can actually do stuff with it. But this parent class, at least in this instance, it's never going to need a collider. I just have it there so I can use it for other power-ups later. Let's just enter a null collider. That's fine. Collider's nullable. So now, let's see this. If I drive through, let me turn that off so it's unshaded. That might be a bit easier to see. So look, driving through that does nothing on the shield because that's just a normal power-up. Whereas here I've got my speed power up. I've extended the class. You can see here the car speeds up a little bit and zooms around. Right? So that was like a really easy way for me to implement a power up. And all I had to do really was update this one function call, which is pretty nice, by overriding it. And you can see how that's easily now extrapolated to a jumping one. So for a jumping one, instead of adding velocity to the car, I could just add a force to it in the world's up direction or the car's up direction. Probably the world, just in case the car's flipped or something weird, right? And then shield, you could do whatever. You could make it instantiate objects and do all other sorts of stuff. But that's just a really simple way to juice up your game. So, for less than 100 lines, I was able to make like a really cool animation, which I think looks really, really nice. It just feels, there's something about it that feels good. I don't delete anything straight away. I make stuff happen over time, and that feels nice. And compare that to this, it's just sitting there doing nothing. Like this is just really, really boring. And you could add a whole bunch of other stuff. You could add particle effects, you could add sounds. I actually muted the audio because the default car is pretty noisy. You can do a whole bunch of stuff. I just find that as a programmer, I tend to skip over this stuff because I want to get the features in. I want to get it to work. That's the artist's job, or it's too hard. I don't really know what I'm doing. Hopefully this video gives you just a pretty good idea of how easy it is to add this sort of stuff. And to be honest, it makes you, when you're testing it as a programmer, have a much better time with it, because I much more enjoy looking at this than I do the stuff down the end. Even when I was originally doing some proof of concept with just plain cubes, just having cubes spin around like this shield instead of sitting static like that green arrow made a huge difference. So if you've got 5 minutes with your game, just like juice it. Spend an afternoon just adding some weird stuff like this. It's like really easy to add in code, and this is robust. Like, it's not going to break. I think that's what makes it really nice. So think about ways you can just add really simple effects without, I guess, spending ages in Maya or in the particle editor, because I still totally don't get that thing. Anyway, I hope everyone enjoyed it, and yeah, as I said, if you'd like to see more, let me know. I'll do my best to try and do some more. I probably will write this up at some point in text format as well, but it's going to be super long. So I'll stick with the video for now and see how we go. Thank you very much.